Thank you. Respected dignitaries of GMRIT, respected HOD of EC department, dear Arun sir, Dr. Arun sir, and all the motivating professors and my ever dearest students, I'm as excited as ever to present Python libraries for data science today. Data science. Recently, I had conducted a 5-day webinar on how to become a data scientist. I would share my PowerPoint presentations with our dear Dr. Arun sir. In all, there would be about 100 slides or a little bit more than that. Those of you who want to gain more insight on data science can use those slides as your notes. All right, dears? Since we are going to discuss Python data science libraries in today's session, we assume that you all know something on data science. Even otherwise, don't worry much. Stay happy and please pay attention now, my cuties, okay? In simple words, data science brings together techniques and theories of mathematics, statistics, computer science, domain knowledge, information science, etc. to understand and analyze big data, data that is freely available in our internet world. Okay, moving on to our first slide of the day. Fantastic. Numpy. Numerical Python. This is used for scientific calculation. Numpy was created in 2006 based on another parent package called Numeric from 1995. As always, Python package installer pip can be used to install additional packages like Numpy. Numpy library provides multi-dimensional array objects. That's what you're seeing in the slide, right? Mostly you see 1 dimension, 2 dimension, 3 dimension, n dimension. So I have, mostly the way I prepare my presentations, or I don't write lengthy or, sentences. I try to put as much pictorial representation as possible so that, one slide would contain as much information as, we need. Most of what needs to be understood and remembered in Numpy is definitely on this slide. Plus, on top of that, you're going to have the recorded version. Please review that now and then in case you want to familiarize your 1, 2, 3 times. If you listen, you will be able to just, remember this by heart and, go on any, like python.org or anything and then kind of recollect this. All right. So Numpy library provides multiple, multi-dimensional array objects and a collection of routines for processing these ND arrays. Wherever you see ND, that's multi-dimensional, obviously, with homogeneous collection of items. Each are used to perform data or shape manipulations. It's very easy using Numpy. Obviously, when you hear the word homogeneous, that means they are of the same data type. Numpy library provides space-efficient, high-performance, vectorized arithmetic, scientific, and logical operations on multi-dimensional or n-dimensional arrays. Okay. Integration with C, C++, and Fortran code. Benefit of using Numpy array is smaller memory consumption and better runtime behavior. We will be seeing the amazing difference in speed between lists, Python's lists, and Numpy arrays in our practical part in a little while. All right. Other than that, what do we see in this slide? Linear algebra. Okay. This means the study of linear equations and their properties in mathematics. It is widely used in engineering. You all know that. covering concepts in physics, mathematics, etc. Numpy has built-in linear algebra module. We see practical examples in a few minutes. Next, what do we see here? Reshaping NumPy arrays in Python. While creating a matrix or tensor from vectors, reshape method can be used to reshape the NumPy arrays from one particular dimension to another, dimensions. For example, you see in the inset, you see 3, 4 matrix is changed to 6, 2 or 2, 6. We'll be seeing practical, example on that in a little while. So it's very important to know how to reshape your NumPy array, particularly when you are training deep learning network. Some deep learning models, like the CNNs or the convolutional neural network, or long short-term memory (LSTM) architecture in Keras. Keras is, something that we'll be going through in a while. Not today though, in subsequent sessions. It's a type of artificial recurrent neural network, RNN. Sometimes reshaping of the original NumPy array is definitely required. So that's why we have to know that part. So I think we covered pretty much everything in the slide. Moving on to the next slide, Matplotlib. Mathematics, okay, plotting and library. So those 3 words together, put together. This package is used for data visualization. Matplotlib is used for plotting high quality charts, graphs, and figures. Matplotlib and NumPy works well together. We will be going over quite a few examples in a practical part of today's session. Matplotlib is challenging, whom MATLAB, with its ease of use. MATLAB is a multi-paradigm numerical, computing environment, and its proprietary programming language it was developed by MathWorks. One question, that we had on our day 1 session was on MATLAB, where someone had asked if Python provides functionalities like MATLAB. I had answered yes then. Today also, my answer is yes. So we will see more relevant code today to support my answer. So Matplotlib embeds plot with a basic understanding by using Python GUI kits, like graphical user interface kits like our Jupyter Notebook. Using Matplotlib on Python is very beginners friendly, unlike the other MATLAB. Since we're learning Python, let's just focus on this. Not only that, it's combining the features of so many different languages in one. So that is why I always say, please focus. Anybody can learn Python, because most of the libraries that are in here just has amazing amount of code in it, which we don't have to know. All we need to know is just how to use it. Okay, so to understand, just when you look at this plotting charts, graphs, that's all we are going to be concerned about in Matplotlib. Based on NumPy and Scipy frameworks, Matplotlib was created not for, not like Python. It just came up only in the this millennium, rather, 2003. Initially, it was built as a patch, to enable MATLAB style plotting in Python. However, after STSci, that is Space Telescope Science Institute, chose Matplotlib as the plotting tool, it gained popularity, and ever since then, there has been version upgrades done to it regularly. As it's preferred by Python developers for visualization, data visualization, it's just getting popular and popular. So as we know, any package with a new package that we have to install, we have to use pip install Matplotlib. That's it. And then you will have it ready. So moving on to the next slide, the fourth slide of the day. Excellent. It's Pandas. Okay. Pandas, however you want to call it. Okay. Pandas are the Python data analysis library, is the most frequently used and the most popular library in Python that is mainly used for in-depth data analysis. Okay, we already saw data visualization using Matplotlib. This is data analysis. It's tempting to start playing with machine language, However, it's always better to understand Pandas well, as it provides the ability to process data munging, and classifying the big data that's available. So it processes, it munges, and it classifies the big data. Pandas was developed only in 2008. And as recent as 2015, Pandas has gained more popularity. So understanding the data structures in Pandas is very important. Okay, as you can see in this slide, there are 3 different data structures based on their dimension: series, data frame, and panel. So series is 1 dimension, data frame 2 dimension, and panel is 3 dimension. Series and data frames are used mostly in data science. Series can be imagined as a single column of an Excel sheet, whereas data frame will have rows and columns, and it can be like a sheet itself. Panel, however, will look like a group of sheets which can have multiple data frames. Okay, this is for understanding purpose. Okay, we can always think that Pandas functionality in Python is similar to Excel functionality in Microsoft Office, for us to just relate. Okay, guys, cuties. All right. So Pandas functions. What are some of the functions? Some functions are D types. Okay. I think I see D type here. No, I don't see D type here. Anyways, we will actually go over those in a little while. So D type means it will actually return the date type of the data, and then empty will just make sure whether it's empty or not. It's going to be obviously returning Boolean. So likewise, there is ndim, that means the number of dimensions that are there, and then size, the size of the data structure itself, and then head, tail. So all of these are like the functions. Let's move on to the next slide. Awesome. Scifi. Python library is used, this particular library, right? Scifi is used in mathematics, scientific computing, engineering, and technical computing. Scifi is the second most used scientific library after the scientific libraries found in C, C++, or MATLAB. This operates on Numpy arrays, as Scipy is built on top of the Numpy. Keep in mind, first initial slide we saw Numpy. So Scipy is built on top of Numpy. That means mostly when I say those kind of things, you have to make sure that Numpy is available in order for you to actually install this, so that it correlates, like there is a relationship between these. It inherits, that's how the code is. It's so easy for us. All we have to do is just be creative and then utilize these. Okay, so Scipy, like I said, since it's built on Numpy, is a fully versioned, the version is completely contains the features of linear algebra. So we can call it as a fully featured version of linear algebra, while Numpy contains only a select few features. Okay, latest data science features are available in Scipy. That's one more thing why it's popular. As always, we have to use pip install Scipy. An important list of the sub-packages from Scipy are listed on this slide. The golden yellow box that you see. I made sure that most of the font size is bigger, so hopefully you'll be able to see. Even otherwise, do not worry. You can always refer it. There is no need. Somebody asked me, why don't you just share the slides every day? There is no rush, okay? Just give us like a break. After when the course is done, we can always, review back everything, have your materials and start learning. So only a couple of more days. Starting next week, you can be the Python guru, okay? And I am going to be contacting you all to know more. And so would everyone in the community, because, Python is free, like it's a collaboration, right? So we all share our knowledge together. So that's good. Okay. So the Scipy sub-packages that are listed in the slide, I have code FFT, that, and one more code I have is for signal. Okay, the IO package within the Scipy has a wide range of functions to work with MATLAB, Wave, CSV file, text file, binary format file, matrix market. There's so much that you can imagine of. So the input-output package just works awesome. Now, Scipy FFT pack, okay, this supports fast Fourier transformation algorithm, FFT algorithm for computing discrete Fourier transformation, DFT, mathematical technique that is used to convert spatial data into frequency data. So I have the code snippet of and the graph, the two-dimensional and the n-dimensional discrete Fourier transformation, it's listed there. Other than that, we have, like I said, the graph that shows the comparison of smoothing filters, linear, and in red, and in the red text box, and is the one that has the starting point. You see, it starts with 0.5. You don't have to get too absorbed in this. Those who need, the Fourier transformation, they would be, like utilizing this. That's what I meant to say. Now, I think it's time to move on to the next slide. Okay, so in the red box, what is referenced? The Scipy.signal is referenced. And in the other one, that's the signal processing is referenced. In the other blue, it's the fast Fourier transformation. That's, okay, being referenced. Cool. So there was also another question the other day. They were asking about, can Fortran and MATLAB, can Python solve? Yes, yes, yes. Always the answer is yes. The possibilities are endless, okay? It's just our creativity that's waiting. In case you want to enhance it more, please always share it with the community. PEPs are there. The Python enhancements projects would be there. And then you would be, your name would pop up there. Okay, so let's just move on to slide 6. Now, PyTorch, isn't that cool? Torch. PyTorch is a deep learning library based on the Torch machine learning libraries. PyTorch can construct complex, deep neural network and execute tensor computations. Okay, PyTorch offers dynamic computation graph, which is the reason why, you can process variables, variable length input, output. So PyTorch quickly became favorites of researchers because of its architecture, the way the architecture was built on. It's so convenient, it's so easy, it offers dynamic computation graph. It's just unbelievable. Once you get to know this, this was developed by Facebook. Cool, right? And it's used by Twitter. Awesome. Now, this made process of deep learning modeling straightforward and transparent to everyone. Otherwise, we would not know what's happening behind. Now we can actually judge what the model is doing and what it's predicting, what's going to analyze. So much more transparency was brought out because of PyTorch. PyTorch operates on tensors and views. Some of these terms, again, please, for beginners, even for, people that are into Python coding, we would not be using each and every part of this. We are going to discuss on the 7 days in our daily work, because it depends on the project, with whatever you're working on. Some kid, was so curious to know more on pointers. When I saw that, the first day itself, I replied to him. Yesterday as well, he asked the same question. So I understand, he's very curious to know more on how to implement the data. But Python is just so high level. You don't have to get to the details of the pointers, unless you need to learn. There's so much more to know here than, whatever you know in the other language. You can just keep on comparing pointers. Just leave, pointers with C for now and focus on what new features are there in Python. Like all of these libraries itself, when you look at this particular library, there's going to be, at least 10, 15 top books in the market. So always, we recommend, please at least, read one book. But I would suggest, get practical, get your hands on it. And, that's the only way that you can learn. Then refer to your book and you can finish the book. So that's how it will be. Some people would say just finish the book and then start. Please do it parallelly, or better, even better, since documentation and everything is available online, code is available. Take the code, put it over there. Most of the code that's published online, or even on some sites, they have a lot of bugs. If you fix that, you kind of understand. Those will be simple bugs, but still your code won't work. Those is, that knowledge, the knowledge that you gain like that would definitely help. Not just, keep on reading the books, okay? And then getting stuck with one thing. Oh, how do I flush the input-output buffer? My dear child, you don't have to, because, Python has so much more to offer. Let's not worry about that. I'm not sure what project you're doing. Maybe the links that I sent you would help. StackOverflow.com would be best, to be a great site. This is the site that, you can put your code on and ask for suggestions. You can actually show or get on GitHub and share the complete thing. Since you're learning, this is going to be helpful. All right. Now let's get back to this. So PyTorch operates on tensor, and it views any model as a direct acyclic graph. PyTorch allows to change the node with ease. Debugging is made possible by many tools. PyTorch's visualization, called Wisdom, VISDOM, is very convenient to use it, as it utilizes the graphical representation. PyTorch also uses declarative data, parallelism. Remember we saw like parallelism? So data parallelism here, what happens is it splits batches into multiple small mini batches and runs the computations for each of the smaller mini batch, small batches in parallel. All right. So the green table on the top, that's why I had it over there. Towards the top left corner of the slide, compares PyTorch with TensorFlow for efficiency. The other table lists out all of the prominent deep learning frameworks. You see, yesterday I was talking about C++ gaining popularity. It's always popular. When has it lost in order to gain back? Everything is based on C++. Our world, the finance world, all of the applications in all of the, the great banks, everything, the code is based on C++. So there you go. That is this table is listing out the prominent deep learning framework that we got. And you should be glad to see TensorFlow. You should be glad to see PyTorch, these names that you know. So some other things as well, you can just say. Now, the architecture sort of diagram, right? In here, just below the title thing, I have the link. It was taken from awesome opensource.com project fast speech. So we have at home, and I believe even on the phones these days, right? You can actually call your personal assistant, right? So that is speech recognition. So this is a model. What you see here is a model that runs on speech data set. When you go in there, you will get some idea in case you want to know more on the deep learning. That's why I gave you that architecture, and along with even if you don't understand the little words in there, do not be worrying about it now. So that should be it for now. And then the last slide of the day for theory. We have to concentrate more on practical part. I have so much to share. Okay, last one is scikit-learn. This is a machine learning library that's used for data modeling. So remember, we saw analysis, we saw visualization. This is data model. So these are all the basics of what data science is all about. So Dr. Arun sir would actually share the other slides that I prepared for my other webinar, not for along with this, not related to this though, but it will be definitely helpful for you to understand in case you do not know where anything falls, the architecture and everything. Okay, so scikit-learn is a machine learning library. It's used for data modeling, and it's built upon scientific Python, Scifi. So scikit-learns, this scikit-learn provides a range of supervised and unsupervised algorithms. That's why you see one butterfly kind of thing. I really like this. You see how there is clustering. You say clustering, which means for grouping the unlabeled data. Cross-validation, that's for estimating the performance of supervised models on unseen data. Even if you do not see the small letters, do not be concerned. Please just look at this and then listen to what I'm saying, okay? So what I said was clustering, we know, is for grouping on labeled data, okay? And classification is like you classify things. So those are all the algorithms that are part of the classification that's given. And then dimensionality reduction is, for reducing the number of attributes in data for summarization, visualization, and feature selection, such as principal compound analysis. Yeah, PCA, I think it's there. Yes. PCA. And then ensemble methods. Yes, ensemble methods are for combining the predictions of multiple supervised models. Feature extractions for defining attributes in image and text data. Feature selection would be for identifying meaningful attributes from which you create supervised models. Parameter tuning is for getting the most out of the supervised models. And then we have manifold learning, and that's for summarizing and depicting the complex multidimensional data. So that is why Python is popular. So we need to accommodate big data in its form, in big data coming from enormous amount of resources. Like it could be anything. It could be a text file, XML file. It could be database. It could be an image file. It could be a sound. Sound coming out of this, like speech recognition. So for each and everything, there has to be a mechanism to handle. That is why Python is popular. Okay, supervised models, generalized linear models, discriminant analysis, naive bias. I see some of the names that are here. I'm just reading them. And, neural networks, support vector machines, and decision trees, all of that mix. So I have the, from where I took this. And I also have the official website, the link given here. So you can always go there. There's so many beautiful examples and everything. So that's it for now with the theory part. Okay, I have more to show. That's why I don't want to even waste time. I want to get out of here. Let's just get out of there. And I'm sorry. Okay, the first practical part is, I already opened the shell today, so I didn't want to waste time. So we know, right? This is our shell, the Python shell IDLE, and I opened my file called the Numpy and the list comparison. Okay. So, all right, cuties, this code, it makes use of timer object, which is a class of thread. Remember, we saw threading module yesterday, and I had promised to show you examples. This is the one. In combination with NumPy, this timer is a derivative. Actually, timer is utilizing threading, in the background. Timer class represents an action that should be run. I'm letting you guys look at the code. That's why I want to talk while you're looking at the code, and then we're going to be running it in a moment. So timer class represents an action. Okay, what kind of action? Certain amount of time has passed. Okay, typically like a timer. Timer class being the subclass of the thread. It can prove to be an example of creating customized threads. Let us run this code right now, and then we will see. Some kid asked me the other day, what is the difference between a module and a package? I'm like, oh my goodness, babies, you have to start these kind of questions. You have to search already. Do not wait for anyone to answer like me. Don't wait for, such a webinar and, ask these questions. This is like a simple thing. Module means what? Like a program. You just run that, and packages contain many such modules. That's like a most basic question, okay? Please enrich your knowledge. Do not waste your time. Please have a moment to relax, but do focus and learn. Ask yourself question, ask your friends question, ask your teachers question. Make you, think. Now, this ran. You see here? What happens is, you see the amazing difference in speed of our NumPy when compared to Python lists. So I have used list over here, and then I have used the NumPy array over here. What happens is, it's actually trying to give me the difference. You see how quick NumPy is when compared to, you see, this is in exponent, like E. Okay, so it's that quick when compared to 0, 0, 0. So it's 0.00000 and then 8. So that's how quick it is. Remember in our, let me close this. Okay. Now, for the advanced learners, I want to show you an article. That article is in realpython.com. Please make a note of this. Real, R-E-A-L, python.com. And I want to show you NumPy. I'm so used to typing underscore. Okay. Performance. This is a beautiful article. See, I actually had it in the favorites to show to you all. Then you have a moment. Okay. Please go through. This site has lots and lots of beautiful articles with code and explanation. See, they are going to eventually, I'm just scrolling down because we are not going to, if I were to focus this would take 1 hour already. So pure Python with the list comparisons, it takes this much seconds, and NumPy takes only this. So I had a very little code, and then still we were able to see the difference. 18, where is 18 seconds and where is 0.32? And TensorFlow on CPU is 1.2. So this is practical comparison. So that's why our Python is utilizing specialized library for, like specific things. So in case you want to be using, like linear algebra, those kind of things, please use NumPy. Okay, scientific thing, Scifi. So scikit-learn is based on Scifi. Scifi is based on Numpy. So we need to have these three in order to work. Good. Okay. Okay, I think on our day one also somebody asked me, right, about, I told you that I will be sharing some sites. So this would be one site other than the python.org. So please use first learn, from python.org and then enhance your knowledge. Since we're talking about a specific thing, I wanted to share this article that lists out, it's like a thesis kind of thing that somebody has submitted, okay? So it would take days for someone, as a beginner to understand everything. Everything is put together beautifully, so beautifully. It's so lucid. The explanation is beautiful. That's what I want to show you. Okay, let's just not even worry about this for now. Okay, I'll leave it like this. Okay, let me go to our Jupyter. I have everything open today. Okay, this is our linear algebra. Okay, the first thing is I'm going to be like zooming in a bit for you all to know. We'll look, maybe this is how much I could go. I could go further, but it's going to get crazy for me. Okay, now we see dot function in Numpy. I like, and most people love Jupyter Notebook because remember I told you we can run code, snippets or code, and we can put them and we can have it as if it's in our notebook, as if we wrote in our notebook. So look at this example. I ran this example and then I got that. So what do I got here? I got, this is the first program that we are seeing on Numpy, right? Dot function in Numpy is being utilized here. Okay, this is like a scalar dot product. And if we are talking about vector dot product, we go in v dot over here, v dot. And so first, let's just explain. I have two arrays. Okay, I have specified the dimension. So the matrix, first matrix, like I said, always Numpy, remember the first slide we saw, it's saved in like a matrix format for us to understand, right? Now, this is how the first matrix is, and the second matrix or matrix, however you want to call it. Scalar product would be this. Okay, so you can do the computation. Since this is not a linear algebra, class, I don't want to go in depth. Okay, and then we have the vector product. So we basically call the v dot. Okay, so this would be the vector product of these two matrices. And then we have the inner function in Numpy. The inner function. Okay. Look at this, right? I have n, look, these two are the arrays. When I give in a function, so what do you think, those who know linear algebra, they can just, grasp it like that. Even otherwise, please go to python.org or, Numpy documentation. It has complete details on, like what is being done. And plus on top of this, use any search engine. You can just specify inner and Numpy. Automatically what happens is it'll give you the list of various articles or code snippets that are relevant to that. Now, I have MathMul, because I'm going to be showing you a lot more examples today. So we have only 20 more minutes. So we have matrix multiplication, that's MATMUL. I multiplied these two matrices, and then we have determinant function in Numpy. I'm using, look, this is it. So linear algebra dot Numpy. So this is a subclass linalg dot det. I'm positive that you all would have learned C in college, or at least Java, and some children you all have Python, I believe, in your curriculum. Usually we would have made use of mat.h in C, right? And we would have been using some functions like ceil, floor, those kind of things. Here, It's a little bit advanced. We are using on matrices, that's all. Okay. Now, in addition to that, even solving the polynomial equation, quadratic equation of the degree 2, isn't that amazing? You know, we all might have learned that, right, when we were little. So, one more example I want to show you is, okay. This is the problem when I'm zoomed, I get lost. Okay. Look at this. Dot roots. That's going to find out the root of this equation. This is the equation. I couldn't do x squared, so it's just x to the power 2 plus 3x plus 3 with the coefficients are a is equal to 1, b is equal to 3, and c is equal to 3, and then it's going to, you know, give us a complex root. If you solve it manually, you can check for the answer, but you know, we utilize this. MP is numpy dot roots of the coefficient. Okay, and then the next one is reshaping numpy, the most important thing that I had on the slide, remember? Okay, we are changing two-dimensional numpy arrays of 3 to, you know, like 3, I mean, it's 2 by 6 into 6 by 2 and 3 by 4. So we're doing all 3 here. Okay, and we are actually, so this is the original shape of the matrix. Let me show you the, that's why I had to be not zoomed so much. Okay, yes. Okay, so the original shape was 2, 6, and it looked like that. However, the new shape is 6, 2. It's like sort of like a transpose matrix. And I changed the form from, so there are 12, basically 12 values. So you can just, possibilities are endless, like 2 by 6, 6 by 2, 3 by 4, 4 by 3, so on and so forth, right? Or one more new shape. This last shape over here, the last shape that's given is a 3-dimensional. So from a 2-dimensional, you're changing into 3-dimensional. This is like a tensor. So we'll be learning TensorFlow in our machine learning. Okay, so let's not focus more here. Like I said, we are using the function shape, reshape. Shape is the current shape, and then reshape is you just do reshape over here. You see reshape, and then you give the desired you know, dimension, and it's going to reshape into the desired dimension, and you'll be able to see. So this was my initially this is how my array, the numpy array is. For simplicity reason, I have given numbers. It's never going to be numbers like this. It's going to be any kind of data that's in real life, right? Any kind of data. Okay, now next, let's move on to okay, graphs. I want to just kill this. Perfect. Okay, so we are importing Matplotlib. Okay, Matplotlib dot PyPlot. You see that over there? See, when I highlight, something happens and you get this, the presenting control, and then I lose focus. It just doesn't let me get back in. There's so much confusion with the Teams done this way. That's why. Anyways, I'm just going to say the words. Please look for it. When I highlight and come back in, there is an issue for me. That's why I'm not going to be touching my mouse a lot. So matplotlib.pyplot, Pyplot, okay, is used for plotting. This particular example is a simple example where I have plotted a line graph. Let me show you more by getting on matplotlib.org. Okay, Let me just show you that. We were here, right? I want to just use this. So let's just go to matplotlib.org. All right. Okay. This is going to be the place where you can actually look at lots and lots of, look, when I click on examples, right? All possibilities of plots, graphs. Oh my goodness, look at the shapes. Some of them are very fascinating. Really fascinating. You click on any specific plot, okay? Let's just click on one. Some of the plots are like really fancier, unbelievably fancier. Let's just click on anything for that matter, okay? Let's just click on this. Hatch-filled histograms. See, superb. You can find the code. Please visit the site, okay, matplotlib.org. Make a note of this, like python.org, matplotlib.org. Okay, so visit the site for to get better understanding, my dears. All right, back to our Jupyter notebook. Okay, so the first code that we have is, look at that. Sample line graph, x-axis, y-axis, as simple, and then I just gave 2, 4, 1, 3, and it just plotted it. So this is very easy. Now let's move on to the next one. This is, okay, a little bit different from the line plot because this is talking about histograms. Again, the data alone just looks different, but the X label, Y label. So here, XYZ is the other name that's being used for matplotlib.pyplot. Now, we are considering the age of population. All of this is, you know, basic graphing, statistics. We all must have learned in school days, right? Sweet days, school days. Now, looking at the, you know, the next one is stack plot, okay? I have some fake data in here, okay, to make believe that I work 24/7 without rest. It's sometimes true, but not always. I'm so funny anyways. It's always better to laugh now and then to get our mood, you know, like it improves our mood drastically because as programmers, you know, we have to think a lot. So I tend to laugh in between to, you know, bring my mood back. Now, look at this. I have used reading, coding, blogging service. Okay, and then I have, they're only 24 hours a day. You know, that's why it's the upper limit is not over 25. In some movie, I remember, you know, somebody said, how long you exercise? 25 hours. And then he says, I actually usually exercise, you know, like 1 hour from the next day. So something like that. So I basically try to, you know, like fake it up so that we have a colorful graph. Now, look at this, right? You see square brackets. So as the name goes, stack of a plot, okay, sits one on top of another. We chose different colors. You know, let's take a look at the plot method one more time, okay? Matplotlib.org. Whenever you see square brackets, that's why I had that on the top. Let me just go here. I wanted to show you that. That's why I actually didn't want to lose time. So I put that. Let's just go there. All right, I'm just going to go there. Look, wherever you see, oh my God, this is also so little. Okay. Wherever you see square brackets, right, in the syntax, it means it's optional. Now, which is exactly why the same plot method behaves and plots differently based on our input. Hope it's clear to some extent to you all. I was primarily going to show you the various supported colors abbreviation anyway. which is towards the end. I have to. Okay, where is that color? There is oh, there. Okay. So these are the, blue, B for blue, G for green, or for red, etc. So if at all we want more colors other than the colors that are defined here, these are the supported color abbreviations, like for single letter coding. So in our code here, that's why I wanted to show you that example. Keeping aside the fun part of, me saying that, I read for so long, sometimes I do, and I service for so many hours, and I code, that's always there, and then blog. Okay, anyways, just look at this, right? I mentioned the color B, and then you see for reading, automatically it's color coded like that. So if you do not want the colors that are there and you want your own color, you want your own, your own different color, then you have to use matplotlib.colors. That's what I wanted to say. Okay, or you can otherwise use the hexadecimal strings, pertaining to the color of your choice. But if a single letter code, then I'm sorry, this is pretty much it, only whatever you see in the table. Okay, super. Let's just go. When it's zoomed, it's just getting crazier. Okay, so the last, okay, this is our, let me show you. Okay, this is our pie. Okay, so how we plot a pie? So we make use of Matplotlib's PyPlot is like an interface that is in Matplotlib. Please go to utilize the matplotlib.org. Just get in there, get in the website, and then you'll be able to know more. So let's just move on to our next example. We have very less time. Okay. All right. Kill that. And then let me go to this. Okay. This is an interesting scatter plot. Okay. That makes use of random method. I wanted to remember I said I will share more useful sites. I'm going to be sharing you one more site today. So other than this, I shared you already the real Python, right? Let me just do this. W3, yes, there. Okay, this is another website. All right, so this is great for beginners. Look at that. This is great for beginners. It has everything, like even if you don't understand, what numbers, what casting means, please feel free, get in here. What inheritance, Python inheritance, they have code. And so look at this. This is file handling. The reason why I wanted to choose this site was, look, we have Numpy and in-depth random part of Numpy. So this is very important because it has probability and statistics related distribution. Are you all able to see this? I'm so sorry if it's little, but please make use of the, I think you can see this, right? w3schools.com. So go in there and then start, looking at this tab towards the left would have, lots and lots of data science and machine learning, part of that. These are all, the distribution, like the binomial distribution, these names, whenever we read it, should immediately ring a bell. Okay, we don't have to, the time to go over since this is a 1-hour session, but please refer to this website, dears. Okay, that's what I wanted to, convey to you all. Now, getting back to our thing, right? One more example I wanted to show you in here. Okay, let's, before we move, okay, before I forget, where's that? Okay, let me show you scikit-learn, okay, because it's about 5 minutes to close, so. scikit-learn.org. So this is the official site. I showed you Matplotlib today, so likewise scikit-learn. Please get in here. Now you go to examples. Look at that. Oh my God. That's what everyone would say. You see? You see? I have classification algorithm listed there with examples, clustering algorithms, we have, you name it, okay? So this has detailed explanation, the data set examples. Please make use of this site as well, scikit-learn.org. The last slide that we saw was based on this. So this is all like I said, everything is gaining popularity only now. So that's why you see this version 0 point something. Okay, now I want to get back to our example here. So basically what happens is we are using our, let me zoom a little bit. We are using Matplotlib's PyPlot, and we are using Numpy. These both go hand in hand in order to generate this plot. So I'm using the, why do we need this kind of thing? Because usually what happens is in here, I'm just showing it simple, very simple way of, explaining as if this was data and how the data, it just could go and, grab random things and then, plot. When you, I believe in YouTube too, there are so many beautiful channels on deep learning. One is called Syntax. Let me show you a couple. Okay. So they have a code on GitHub as well associated. What they do is they try to take the IMDb database, the movie website database, the reviews from the movie database. They would take the characters, the words from the movie, IMDb movie database. And what they do is they actually display, if they want to just, kind of aggregate the words, the most commonly used words, or, maybe they are using that in their model, the deep learning model, to analyze the sentiment of a person, whether it's a happy movie or a, whether they are getting good reviews, whether, the reviews not that great. So these kind of things would be actually impossible for, us to check, us meaning like any person to sit in. We create models, we create deep learning models that goes and gathers the data from those kind of sites. It web scrapes, it just scrapes the data from there, and then it actually displays it in a user readable format. Okay, so but this is an example that is mimicking, I wanted to show you that we are making use of scatter plot that's available in Matplotlib. Normally it's not going to be just, using numbers, and, this is just to get an idea of that. So in those kind of YouTube, sessions, courses, it's all free, right? Anyway, since it's YouTube. So they have like a series of things like, where they start, where they end. Even there are beautiful gamings that are, taught in various sessions. Towards the end of the seventh day, maybe I'll, go over some on, how you can enhance. Now, one moment, just look at this. There is number 15, and you see these plot. Now, I'm going to show you if you change it to 25, what happens? The plot is big. So assume these are data, and then, if there is more such, like I said, if we are talking, we're aggregating, like positive words, good words together, that kind of thing. Again, creativity, right? Data science is all about creativity. You represent anything that's in real life as in visualized, like data visualized graphs, or you want to train your model based on the data. You want to like reduce the data that's going to be sent to this thing. You split the data. So all of these different packages go hand in hand. Okay, we just have to know the functionality initially. When we know, we will just, when we come up like, a problem in a real time, we would think, okay, I have to use that for this, that kind of thing. We relate and we learn. So this is our scatter plot. What else was I going to show you? I was going to show you the data structure. Okay. Let me zoom it a bit. Okay. Pandas, like I said, we have series, and then we have, there were 3, okay, data frames, but we do not show panel. I know it's almost time for us to leave, but, I want to show this alone. Please bear with me. Okay. So we are importing pandas as PD, and then this is the series data type. Okay. Remember I said there was something called D type over there. So when you print it, so it's going to print by default this is just again some value that we gave for simplicity purpose. Now, if you want to re-index, usually the index is 0 to 4. If you want to change the index on your own, then you can specify it as well. So I have given the index as, please do not be thinking what an index is. Please, please, please. You should know index is kind of like a reference to something. So if it's a dictionary, so there is always an index and a value, as in this case. Okay, so A, and this over here is the index, and this would be the value. Okay, so series, you have a series, you have the data, and then the index. In case you want to change the index, you want to give a name to it, you can do that. Now, we have the dictionary defined here. So dictionary is usually in curly braces. I already taught you. But there's so much more to know. Do not get, cracked in only, oh, just I need to learn this. No, please get to code. You will know. Make a mistake, make lots of mistakes, you will know. And please use the IDEs, they are more helpful. It's going to be easier for you to understand, and the last part of this is, before we go there. Okay. All right, I want to show you, this is called slicing. Okay, it's called slicing. Now I want to show you, okay, there, I want to show you this. We have a dictionary, and we have our principal, sir, Dr. Prasad Garu sir's, name in there, and then occupation. So we tend to understand that this is actually the information. Honestly, this is the information that was there from the file that I took the other day. But, I keyed in the values. I copied that and pasted in here. But if you were to not do it, since we are explaining, I'm doing it this way. In real time, what we do, we read the file, we extract, we use the file handling mechanism that we learned the other day, and we store them in our, in this case, a dictionary. And we, this is called a data frame, rather, we call this as a data frame here. But this itself, you can call it as a dictionary because it's in curly brace. The data is called dictionary over here. You can name anything. It can be, patrons. So I gave in principal sir's name, assistant principal sir's name, and our dear Dr. HOD sir of the EC department's name, and our Arun sir's name in here, and their occupation. So I have given to, look at this name. It's not going to be always the 0 index. Okay, so that's why I want to mention you can actually specify your own index name. So here the index name would be name. When you go to Pandas, right, you can actually, there are so many, just search up code. You can manipulate. Assuming this is how it is. I wanted to change my index to be first, second, and third and fourth. So this would be the first level of contact, second level of contact, third level of contact, or it should have been otherwise. Anyways, I have the thing listed here. What I meant to say was, in case you want to assume this is again like an Excel file. Think this is an Excel file, and this would be your the column and the row format. You see, this is the first column, this is the second column. You want to add more columns, you can add. You want to, like do something with this, you can do. That is what we do in real time. So we use data frames. Like I said, in Pandas, data frame, if you think of Pandas, it's like Excel. That's what you should think. Okay, super. Now, what else is it going to? Are there any questions, sir, so far? Arun, sir?
Ma'am,
yes,
no
sir.
questions.
Ravi, sir? Yes.
No, ma'am, no questions.
Oh, good. Okay, sir. So maybe even if there are questions, let them post on the thing, and we can always get back to them. So should I already showed mostly whatever I was going to show you. One more beautiful thing before we end. Okay, so this is a logo. Look at that. Isn't that cool? This is a 3D. When we were learning computer science, right, we had a separate semester of computer graphics, and we were trying to use RC for that. We had lab session, and we were trying to be creative, but just few lines of code, and look at that. How cool is that? It's 3-dimensional. This again is an example that I took from Matplotlib.org. There are so many code, so much of beautiful explanation given everywhere from the official sites. Utilize them. So I wanted to show you this because look, I told you, remember, you can use the hexa. I'm not sure if everyone is able to view it. Okay. See, hexadecimal representation of your color. So that's why we say beautiful purplish blue and then golden yellow color kind of thing. Okay, and then this is again all math. This is all math. And we have so much of code snippets. Look at this. We are importing. This is for 3D. There is for especially for 3D Matplotlib's 3D representation, mplot 3D, and we use this. Please get your hands practically, like work on, even if you don't know, copy the code, paste it on the environment, run it, and then see how it works. And that'll be a starting point. Should we meet up tomorrow, sir? It's past. I don't want to be boring for the kids. Palm. If there are no questions, maybe we can, like wind up, wrap up for today. And maybe tomorrow we can meet again.
Okay, ma'am.
Thank you, ma'am. Thank you very much.
Thank you, sir. Thank you so much, sir. Thank you so much.
Thank you for your wonderful session, ma'am. Thank you, participants. We will meet tomorrow exactly at the same time, 4:30 p.m. Thank you, one and all. Now I am signing off.
Thank you, sir. Thank you.